An ECG records the electrical activity generated by heart muscle depolarizations, which propagate in pulsating electrical waves towards the skin. Although the electricity amount is in fact very small, it can be picked up reliably with ECG electrodes attached to the skin. The full ECG setup includes at least 4 electrodes, which are placed on the chest or at the 4 extremities. An ECG electrode is typically a wet sensor, requiring the use of a conductive gel to increase conductivity between the skin and the electrode. In 1786, Dr. Luigi Galvani first noted that electrical current could be recorded from skeletal muscles. He recorded electrical activity from dissected muscles. In 1842, Dr. Carlo Matteucci demonstrated that electrical current accompanies every heartbeat in a frog. 35 years later, Augustus Waller published the first human electrocardiogram using a capillary electrometer and electrodes placed on the chest and back of a human. He demonstrated that electrical activity preceded ventricular contraction. Dr. William Einthoven, a Dutch physiologist inspired by the work of Waller, refined the capillary electrometer even further and was able to demonstrate 5 deflections we see today. The term electrocardiogram is used to describe these waveforms. Here is a scanning electron microscope picture of the electrodes used. The ECG machine consists of electrodes, connecting wires, a storage and transmission device, and an amplifier. The amplifier consists of a diode, which we will look at more closely now.
Some everyday objects that contain the diode are traffic lights, vending machines, scoreboards, the radio, and LED lights. There are many different types of diodes, which include the thermionic diode, the semiconductor diode, and the light-emitted diode, also known as LED. In the 1800s, William J. Hammer discovered the heat-induced charge in one direction, also known as thermionic emission. J. A. Fleming used this effect to invent a detector for radio signals, in which he patented the thermionic diode. In the 1930s, the work of C. E. Fitts in 1886 was retrieved as an efficient way to convert AC voltage to DC voltage in industrial applications with relatively large power requirements. Nick Holland-Yock Jr. of the General Electric Company has been called the father of LED for developing the first practical device that emitted the visible spectrum in 1962. In conclusion, this success is a result of many scientists. Therefore, there is more than one inventor of the diode. Diodes are made from 2 differently doped layers of semiconductor material that form the p-n junction. In the middle, where the extra electrons combine with the extra positive charge, it will cancel out and create a thin layer of neither positive or negative charge. Therefore, diodes allow current to flow from the anode to cathode. The diode has many applications in society. It can convert AC power to DC power. It can isolate signals from a supply, control the direction of a current, and it can also control the size of a signal. This material is used in many electronics in order to regulate the voltage and current. Thus, there are many different types of diodes. This can protect the circuit by only allowing the current to travel in one direction. Without diodes, many of the advanced machines that are present today will not efficiently carry out its function. In 2012, about 49 million LEDs were installed in the U.S., saving about $675 million in annual energy costs. This can reduce electricity consumption for lighting by nearly 50% and avoid 1,800 million tons of carbon emissions. This is all due to the fact that LEDs are much more efficient as compared to incandescent light bulbs. An interesting fact about LEDs is that energy is consumed more efficiently with little waste heat as compared to incandescent light bulbs, which release 90% of their energy as heat.